Okay, so once again, we already finished with our course syllabus. So this time, we may proceed to our chapter 1 discussion. May I request anyone to please turn off your video, your microphone for a while.
Kasi ako naman ang wala ng trade.
Okay. I turned them off. Okay, so we have a lot of commercials. Okay, so introduction to data structures and algorithms are a building blocks of a computer science, information technology, and information system. It is the study of organizing, storing, and retrieving data efficiently using various techniques. So the algorithms provide a step-by-step approach to solving a problem. So in this lesson, we will discuss data structures and algorithms, their types, and its application. So, data structures are the way of organizing and storing data in a computer system so that it can be accessed and manipulated efficiently. So, data structures provide a means to manage large amounts of the data efficiently for different type of operation. And some of the commonly used data structures are, number one is arrays. During your programming 1 and programming 2, your professors maybe give you a lot of examples on how you'll be able to write or to run a program using arrays. Arrays are a collection of similar elements that are stored in a contiguous memory location. Let's say we use array, let's say numbers, or letters, or alphanumerics, and so on. Because it is used for storing homogeneous data, and it provides random access to elements. So another one is the linked list. Linked lists are a collection of nodes that are connected to each other. So each node contains data and a reference to the next node. So it's used for storing heterogeneous data, and it provides dynamic memory location. So if you are already done with, of course, your logic formulation, some technical or hardware courses, especially if you have a background with networking, it's too easy for you to understand linked list. Now, another is stacks. Stacks are a collection of elements that follow the last in, first out, or the LIFO principle. It is used for backtracking problems like parsing and expression evaluation. Next will be the key or queues. Keys are collection of elements that follow, this time, the first in, first out, or PIPO principle. It is used for scheduling, network routing, and breadth first search. Typically, let's say, for example, in operating system, we have different types of scheduling. First come, first serve, priority, what else? Round robin, and shortest job first. This will be the type of scheduling. Network routing, of course, and the breadth first search. Number 5 will be the trees. Trees are a collection of nodes that are connected to each other in a hierarchical structure. So it is used for representing hierarchical data, such as file system and organization charts. And the last one, of course, is the graphs. We need to take note that graphs are a collection of nodes and edges that are used to represent relationship between objects. It is used for representing social networks, transportation systems, and circuit designs. More on electronic, of course, especially if you have an idea about logic design in circuitry, now it is too easy for you to understand the graphs. Now, algorithms are a set of instructions that are used to solve a particular problem. So, it means to say that algorithms provide a step-by-step approach to solving a problem. And some of the most commonly used algorithms are, number 1 and most commonly used is sorting algorithms. When we say sorting algorithms, this will be, or a system sorting algorithms to arrange elements in a particular order, such as ascending or descending order. Like say from series of number from 1 to 20, that is 1, 2, 3, 4, 5. But when we say descending order from 20 to 5, so 20, 19, 18, and that is what we call sorting algorithm. Some of the most commonly used sorting algorithm are bubble sort, no, selection sort, insertion sort, merge sort, and quick sort. Actually, you will be able to use this sort in a programming language. No, our asynchronous activity, you must provide me a program. Let's say, for example, sorting algorithms, which all of you are required to submit bubble sort program. Example: selection, insertion, so merge, and quick sort. No, algorithm. Right after, of course, the most commonly used sorting algorithms will be the searching algorithms. So, searching algorithms are used to find a particular element in a collection of elements. No? So, most commonly is by bundle, no? Same with an array. And some of the most commonly used searching algorithms are linear search and binary search. Okay? Number 3 is the string algorithms. The string algorithms are used to manipulate strings, and some of the most or commonly used string algorithms are string matching, edit distance, and longest common subsequence. And number 4 is the graph algorithms. So graph algorithms, on the other hand, are used to traverse and manipulate graphs. Some of the commonly used graph algorithms are breadth first search, meron din tayong depth first search, meron tayong tinatawag na Dicard-Trust algorithm, and Bellman-Ford algorithm. Data structure and algorithm are fundamental concepts in computer science, IT, and IS, and are essential for solving complex problems, as I mentioned earlier. Okay? A data structure is a way of organizing and sorting data so that it can be accessed and manipulated efficiently, while an algorithm is a set of instructions for performing a specific task or solving a problem. And there are numerous applications of data structural algorithms in IT education, such as I mentioned earlier, search and retrieval. Because data structures like arrays, linked lists, binary search trees, and hash tables are used for searching and retrieving data efficiently. No, in your programming language, especially in programming 2, no, if you will be able to continue up to the trees, no, up to the sorting and so on, no, you will be able to understand what I'm saying. No, then of course, search and retrieval, then sorting. Algorithms like bubble sort, insertion sort, merge sort, quick sort, and hep sort are used for sorting data in ascending or descending order. We will going to give more data or information about the available sort and available search and retrieval functions for the entire semester now. Then number 3 is the graph algorithms, as I mentioned earlier. Graph algorithms like breadth first search, depth first search, Bellman-Ford algorithm, and Dicard-Trust. Nabubulol ako dito lagi, no? Such as finding the shortest path between two nodes. I don't know if you could able to still remember, no, during your logic formulation in first year, no, intro to computing, no, there are certain computations wherein you could able or you are required to find a shortest path. Let's say, for example, if you were going to Quiapo, no, from Pateros or from Taguig, and if you wanted to find out which will be the shortest path, no, saang way ang mas maiksi ang makukonsume mong pera at the same time, mas maikli makukonsume mong time at mas maliit ang cost. Yun yung tinatawag natin shortest path. Pag na-determine natin yun ang tinatawag natin critical path. Okay? Then elaborate yan more actually in some other subjects. Okay? But I think the introductions must share, no, these thoughts in your introduction to computing. Now, The next one will be the dynamic programming. So dynamic programming is a technique used to solve complex optimization problems by breaking them into a simpler sub-problems. No? So from a larger problem to a simpler sub-problems. Because algorithms like the knapsack problem, longest common subsequence, and matrix chain multiplication are solved using dynamic programming. Number 5 is the computational geometry. Data structures like binary trees, KD trees, and quad trees are used for solving geometric problems such as point location, nearest neighbor search, and range queries. And the last one is the artificial intelligence and machine learning. Many artificial intelligence and machine learning algorithms rely on data structures in algorithms such as decision trees, neural networks, k-means clustering, and support vectors machine. To cut it short, data structure and algorithms are fundamental concepts that are widely used in computer science and IT for solving complex problems efficiently. And by understanding this concept and applying them appropriately, you can develop efficient and scalable solutions for a variety of problems. That's how data structure algorithm is very important in our field as an ITE practitioner right after your graduation. And maybe somebody, since you are in an executive class, there is somebody who are presently working in a well-known company who are also using some programming languages and apply all what I have mentioned earlier. Okay, now we may proceed to with number 2 topic. Okay, but prior to that, I just want to play a video presentations on the discussions about the introduction to data structure. Wait, I hope. I'll just actually this is just only an additional information on what I have mentioned earlier. Because I believe that if you've heard a topic or a lectures or the discussions not only once, it's too easy for us to of course to observe all the data and informations that we've heard in the discussions or even in video presentations.
Welcome all. From this presentation onwards, we will study a new subject, that is data structures. And in this presentation, I will introduce what data structure is and some real life examples of data structures. So let's get started. Before understanding what data structure is, let's first try to understand what is data. This is a prerequisite, okay? The better definition could be a dictionary definition. So let's see what is the dictionary definition of data. The quantities, characters, or symbols on which operations are performed by a computer, which may be stored and transmitted in the form of electrical signals and recorded on magnetic, optical, or mechanical record. This is what data is. You can think of a data as quantities, characters, or symbols on which we can perform operations, we can store them, we can transmit them, obviously in the form of electrical signals in our computer, right? So this is what data is. Now let's see one example here. Here in this case, I'm performing this operation on these two data, right? We can think of these two as data because we are performing operations on them. These are just quantities, right? We can store them, transmit them. So they are satisfying the properties of data. So I can say that these are my data. Now, let's try to understand when data becomes information. There is a distinction between data and an information. And it is one such topic which is very confusing. We often use these two terms, right? But there is a distinction between data and information. Let's try to understand what is that. I say just collection of characters like this or collection of symbols like this, and this is just data. Because it is just a collection of characters, I won't be able to understand it properly, right? Can you tell me what exactly I've written over here? No, right? But when I process this data and let's say I reverse this whole string, means the last character becomes the first character, second last character becomes the second character, and so on, then it becomes an information. Because now I can read this and I can understand what is written. Here I have written my name is Jaspreet. So it is quite understandable. So I can say that now here data becomes information because I can extract some meaning from it. So if data is arranged in a systematic way, then it gets a structure and become meaningful. Here I have arranged the data in such a way that it becomes meaningful for me. Therefore, I can say that this meaningful or processed data is called information. Now, it is not difficult for us to understand that the data needs to be managed in such a way so that it can produce some meaningful information. We need to arrange our data, we need to manage our data in such a way so that we can produce some meaningful information. To provide an appropriate way to structure the data, we need to know about data structures. That is why it is so useful to understand data structures. Data structure gives us the way to structure the data, to appropriately manage the data so that we can get some meaningful information from it. And not only that, we can use it whenever required in an efficient way. This is the reason why companies are preferring this subject over other subjects, because this is very important subject, right? Now let's understand what is a data structure. A data structure is the systematic way to organize data so that it can be used efficiently. So organizing the data in such a way so that we can use it efficiently is what data structure is all about. We are arranging the data, we are organizing the data, we are managing the data in such a way so that we can use it efficiently. When I say efficiency, I mean in terms of time as well as space. Let's see one example of a classical data structure, arrays. We have used it many number of times. We can think of it as a sequence or collection of some symbols, characters, integers, floats, or something like that, right? You can think of array as a data structure because it is helping us in managing the data in an appropriate way, actually in a sequential manner. Now here is an example why this data structure is so useful. Instead of creating multiple variables of same type, why not create an array to store all the values? Let's say I need 100 integers. Why do I require to create 100 variables for 100 integers when I can create a single array and store all the integers in them? Isn't that so? That is why arrays are so useful. Or you can think of one example like storing strings. You know that strings are nothing but sequence of characters, right? Let's say a string consists of 100 such characters. Now, are you going to create 100 variables for that? No, you can create one array which can store that whole string and we would be able to access it very easily. Isn't that so? So this requires array, and that is why we need arrays, because it helps us in managing our data in an appropriate way. That is why it is a very useful data structure for us. Now, let's discuss some real life examples of data structures to help understand why do we need data structures. Here is an example. Did you know that stack data structure is used in implementing redo and undo feature? You know, this is the famous feature which we are using many number of times in our applications, right? One such application is Google Docs or PowerPoint or Microsoft Word. Redo and undo feature is very famous. But did you know that stack data structure is used in implementing this feature? Let's see how. Here I have taken an interface of Google Docs. Here I'm going to write something. Let's say I have written the primary goal of Nesser Academy is to give quality education. I want to write education here, but I forgot to mention here you. So instead I have written education, something like that. Let me tell you that here a stack is maintained where each and every information that I have entered gets stored. Like in this case, quality is stored ed is stored separately, cation is stored separately. So this is our undo stack. Okay, we know that in stack the data is placed from top, and whenever we want to get the data, we can get it from the top. Only the top element we can access, right? Now, when I press Ctrl Z, then I know it means undo, right? So what it does is it selects the top element and it pops that element out of the stack and placed it in the redo stack. That is why we can see here that cation get removed when I press Ctrl Z. Ctrl Z means undo the operation which I have performed. Here in this case, I have entered cation. I just can remove that out of the stack, and then after that, that particular element will get placed within this redo stack. Why it is placed in this another stack? Because when I press Ctrl Y, that is redo, then we can get that again. That is this cation, I would be able to get that again over here. Maybe I want to redo my operation. That is why redo stack is also required. Now I can continue writing. I have written the primary goal of Neso Academy is to give quality education to, actually I want to write everyone, but accidentally I have written every instead of every. I press Ctrl Z, this element gets selected, and it will get popped out of the stack. It will get placed within this redo stack. And you can see here the operation is undone, right? Now let's say I want to redo the operation. When I click on Ctrl Y, then this particular element gets selected and it will get popped out of the stack and will get pushed within this undo stack once again. So here the operation is redone. This is how undo redo feature works. And this is one such application of data structure. And you can see here stack is our data structure. Now let's see another example. Which data structure is used to store an image as a bitmap? Do you know which data structure is used to store an image as a bitmap? There are two types of images, bitmap images and vector images. Now, when I talk about a bitmap image, do you know which data structure is used to store that image? Guess what? It is an array. Array is so useful that it is used in storing an image as well. Let's see how. Bitmap images are stored as a series of tiny dots called pixels, right? So here you can see in this image that these tiny dots or squares are called pixels. Here each pixel is actually a small square that is assigned a color and then arranged in a pattern to form an image like the following. So you can think of a two-dimensional array like this. Here in this example it is 37 cross 40. Now within that two-dimensional array you are storing pixel information. That is each pixel color you are storing, and then after that you are arranging it in a systematic way, and finally we get this as a result, that is an image of a Pikachu, right? So a two-dimensional array of size 37 cross 40 is enough to store this image, isn't that so? Now let's see our example number 3. Storing the friendship information on a social networking site. Do you know how Facebook is storing the information of friends? Let's see an example here. Let's say James is a friend of Mark. Not only that, James is friend with Leah as well. So here we are maintaining the connections between them. This particular edge is representing the relationship between James and Mark. Okay. Similarly, James is friend with Leah and it is represented by this edge. Not only that, Lucy is friend with both Mark as well as Leah. So here I'm maintaining the connections like this. But it should be noted that James and Lucy are not friends. That's why there is no edge between them. You can guess that which data structure is used to store this information. It is graph. Graph data structure we can use to store information like this. And now you can understand why data structures are so important. They are useful in day-to-day life and we are using them more frequently, and that is why it is so hot subject in IT industry. Okay friends, this is it for now. Thank you for watching this presentation.
Okay, so as what the example is much detailed, no? And I think you could able to understand that data structure algorithm fundamentals concept, of course, solving complex problems efficiently, and this concept and applying them appropriately, you can develop efficient, scalable solution for a variety of problems. No, So we may proceed to week number 2 discussions.